Hello guys, I am going to discuss a problem that is viewer suggested problem lecture 1, and the problem says that let Fn denotes the number of the all non-negative integral solution of the equation a plus b plus c plus d plus e equal to n if the value of summation over r equal to 1 to 11 r into f of 11 minus r equal to p c q. C is the binomial or combination, whatever you say. P choose Q, whatever you say. Where P is greater than 10 and Q is greater than 6 and P comma Q is a natural number, then find the value of P plus Q. If you want to try yourself, please do pause the video here and follow and join with us in the chalk option in the Facebook page, Instagram and Twitter, and you can also follow in the Telegram too. At first, you have to know that f of n is equal to n plus 4 combination 4, or you may say n plus 4 choose 4. So how did you get this solution? At first, there is a formula that for the number of the solution, the non-negative, obviously, that means it includes the 0 and positive number. For that case, the solution, if there are r variables and their summation is n, then the number of solution is n plus r minus 1 combination r minus 1. So we can write these from that formula, and if you want to derive this formula, you can consider that you have n number of identical balls and r number of identical sticks. Now, not r number of, actually that is the r minus 1 number of sticks. Because I want to consider the problem as that the number of balls between two sticks are the solution of the problem. So we have to we can we can easily from the basic theorem of the permutation combination, we can say that we can select or we can arrange the n number of balls, n number of identical balls, and the r number of r minus 1 number of identical sticks can be chosen by n plus r minus 1 factorial divided by r minus 1 factorial into n factorial. So that is nothing but the n plus r minus 1 choose r minus 1, and we are getting this solution. And the problem is suggested by Reso or Robin, whoever. So he has written his problem, and he also written his doubt that he has the problem, or the he is getting that he has not considered that the term that non-integer. He has considered the only positive term. That's why he is getting wrong. So you have to consider that it is the solution for non-negative. That is means you have to include 0 and also the positive number. The next, we know that n choose r plus n choose r plus 1 equal to n plus 1 choose r plus 1. This is the basic formula you must know, or you can derive this. Now our next claim is that if you sum over n0 to p, then and mm, n plus r choose r, then the result becomes p plus r plus 1 choose r plus 1. And if you want to derive this, it is very easy. The first term is r choose r. Now you can write that r choose r as r plus 1 choose r plus 1, because both value is equal to 1. And if you write this in this way, then you will observe that the if you consider the next term, that is r plus 1 r, it becomes that r plus 2 r plus 1. Now from using the next term and next term, you will eventually get that p plus r plus 1 choose r plus 1. And it is very easy to prove using the second formula. Now the problem is that you have to sum over the from r equal to 11, that is r into f of 11 minus r. Now you must observe that if you put r equal to 0, then it is 0, so we can include that part. Now we can write that summation over r equal to 0 to 11 r into 15 minus r choose 4, that is straightforward. Now we can also write 11 plus r minus 11 into 15 minus r factorial divided by 4 factorial into 11 minus r factorial. And we can also write in a simpler form, that is summation over r0 to 11, 11 into 15 minus r choose 4 minus 5 into 15 minus r choose 5. Now if you use the third formula of the previous page, you will get the summation, that is 11 into 16 choose 5 minus 5 into 16 choose 6, that is nothing but equal to 16 factorial divided by 10 factorial by 5 factorial minus 5 into 16 factorial divided by 10 factorial into 6 factorial, and that is nothing but 16 factorial, 16 choose 10. And why not 6? Because that is the by condition q must be greater than 6, so that's why. So p plus q must be 26. That is the unique solution. And also you can solve this in a little bit different way, because it is given, and you can also write that summation over r equal to 0 to 11, 11 minus r into r plus 4 by 4. Sorry, I have a step jump a line, that you can write that summation over r equal to 0 to 11, 11 minus r into f of r. You might observe that the first line we have just going forward, and the second line we are just going backward, just the opposite direction. Because I want to solve this in a different way, but we will eventually get the same solution. So summation of r equal to 0 to 11, 11 into r plus 4 choose 4 minus 5 into r plus 4 choose 5. We can write in this way for this case. And obviously the formula, that formula, we can sum the result within a second, that is 11 into 16 choose 5 minus 5 into 16 choose 6. And he has also sent me a solution that is 10 by Reso, and the solution is a little very longer, and you might don't understand what is going on, because in the maximum case he has written that dot dot dot, and it is a very difficult to solve in this way. So thank you for being with us in our journey, and thanks for 1K plus subscribers. Stay healthy, stay safe, and if you have any doubt, please don't forget to send us in the Twitter or Facebook page or in the Google form, whatever you feel the easiest way. If you feel that in the Telegram channel you want to send us, or in the discussion channel, you can send me to. Thank you.